The next transformation that we're going to look at is the rotation. And I feel like I just want to show you an example and define the terms as we go along. Let's suppose we've got a point here. This point 2, 4 right here. Okay. And let's suppose I want to rotate that counterclockwise. Okay. So let's suppose we want a 90-degree counterclockwise rotation. Counterclockwise rotation. Now, okay, so what does that mean? Well, it doesn't mean much until we say about a fixed point. Let's say about the origin. Okay, so when we talk about rotations, we have to have a point of rotation, a fixed point, a center point of the rotation. So here we have an angle of rotation and the center point of the rotation. Okay, now we've got a point here. Let me show you what this means. Let me maybe color it. I'm going to make a little rectangle here. When we talk about rotating this 90 degrees counterclockwise, here's what we mean. Think about this rectangle, and I've got the point right here. Think about if I just move that rectangle, just rotate it over 90 degrees. In other words, what I'm going to do is I'm going to get a rectangle down here that looks like this. And here is the point, okay, right there. See, this point that was 2, 4, just think about if I took this rectangle and just laid it over, rotated, remember I'm rotating it about that point. So just imagine the pivot point right there, and you just lay that rectangle over. So now you've got that point, okay? Notice now it's, instead of standing upright, it's laying over on its side. And we've got this point now. Dig this. This point over here is now -4, 2. So notice what happened with our 90-degree rotation. Let's just look down here. We had a point. Okay, so this was the initial point. And the initial point was 2, 4. Okay, now we have rotation. And, okay, so we have a rotation of 90 degrees, let's say, 90 degrees, okay? And now the new point. Okay, our new point is -4, 2. So notice what happened to that point, okay? It's now -4, 2. So it was 2, 4, now it's -4, 2. Now let's go another 90 degrees. Let's do 180 rotation, okay? So now picture this rectangle. It's going, okay, so look at this. It's 90 degrees here, and then it gets rotated another 90. Okay, so what would that look like? Well, now you have this situation. You have a rectangle that looks like this. Okay, and now think about where that point is. Just think about it. It'd be right here, right? See? Remember, it's pivoting around this thing. So now we have the rectangle down here, and the point is now, let's see what it is. Well, it's -2 and down 4. Okay? So -2 down 4. So notice what happens on the 180 rotation. And keep in mind always comparing that to the initial point. What's happened to that initial point when we do these rotations? Okay, see? So see if you can see a pattern here. Okay, now we rotate it 90 degrees, 180. Now let's go 90 more degrees to 270. Okay, now remember, this thing is just pivoting around this center point here. So let's think about the new rectangle, what it would look like. Be this one right here, right? And of course, here is our point, right? There's our new point. So you just imagine, so we went this way, 90. Whoops. We went 90, 180, and then 270. Okay, that's how it goes. Okay, so let's see what the new, whoops, let's see what the new angle is, or the new point is. Okay, so let's just see here. This is 4 and -2. That's the new point. Now, this is what we call a counterclockwise rotation. Okay? And let's see if we can make sense of this. Notice we were just rotating one point there, but ultimately we're going to rotate a figure, which is just a bunch of points. But let's think about how this would be. We start off with XY. And after 90 degrees, let me make a different color here. Okay? Let me make this maybe a purple here. Okay, so we start off with an XY. With a 90-degree rotation, what happens? Well, we swap the X's and the Y's. Whoops, I was looking at that thing up there. So this is X. See? See how 2, 4 became -4, 2? See? We swap those. Now, so we're looking at kind of a formula that if you want to, you can memorize this. Now for the 181, now it's just -X, -Y. See? So dig what happens. You can look up and see how we're just generalizing. We're coming up with an argument here. Or not an argument, but a little way that we can identify the rotated points. Okay, then we've got 270. Okay, let's think about what that was. Well, this is now the X coordinate, the Y, and the X is negative. So look at that. It's -YX, -X, -Y, and Y -X. Okay? So, and really the only rotations we're going to look at are going to be 90, 180, and 270. And this is general. So I'm going to say this is general. Clockwise, counterclockwise. Okay, this is just the general situation for counterclockwise rotation. Okay, so we've got these counterclockwise rotations. Now, let's look at a clockwise rotation. This time, I want to go in the clockwise direction. So let me put this here. Let's go clockwise. Let me take out this 90. We'll look at clockwise. Okay. Now, we're going to work through this exactly the same way, but look what happens here. So I've got my rectangle like usual. And this time, you know, I've got my point. So let's look at this. We have our initial point, which is going to be 2, 4. And we want to go a rotation. And this is the new point. Okay, so let's do the 90 degrees. This is the clockwise, okay? So now we've still got our pivot point here. So imagine this thing being rotated 90 degrees. And what we would have is this thing, okay? And there's our point right there, which our new point is 4, -2. Okay, there you have it. Okay. Now we want to go another 90 degrees. Okay, so imagine rotating another 90 degrees. That would put us over here. And there's our point now. And notice that point, so this is 180 degrees. And notice our point now is -2, -4. See how it's matching up kind of, we're just going in the reverse order. And then let's look at 270. Okay, 270, well, we do this again, and we get, whoops, we get our point over here, which is -4, 2. Yeah. So there we have it. So that's the 270 rotation. So you can see we could talk about a general, okay? So we could talk about general case. General clockwise. Well, you're going to have X and a Y. And then if you have a 90-degree rotation, that's going to be, let's see here. Let's see what we did. We had the Y and -X. Okay, maybe I need to bring this up a little bit. Bring this up. Okay. And then when we had 180, when we had 180, we had -X, -Y, and then 270, -Y and X. Yeah, there you have it. So this is something that you can remember. I mean, if you want to, you can put this in your, your knowledge pot and just have it if you want to memorize that. Or you can, every time, just kind of work through it. Okay. What I would do, sometimes you might have a situation where it's kind of complicated to actually work through it the way I did here. What I'm saying is work through it. If you just start off with a point and look at the rotations and see what happens, it saves you having to memorize it. In other words, instead of memorizing these general counterclockwise, general clockwise, memorize the process that we work through for these things up here. Just memorize that process, and you can always, get the information back by going through the rotations. Okay, now, so let's look at a triangle here. Now, I've got I've got these points. So let's look at the points from this triangle. Okay, so we've got the points. And let me just write them here. I've got the point 2, 1. I've got the point, let's see here, 1, 2, 3, 4, 1. And I've got this other point. I'll tell you what, the triangle got skewed off. It got moved a little bit. Okay, 1, 2, 3, yeah. And then we've got 1, 2, 3, and then 1, 2, 3, 4. So 3, 4, I believe is the point. 3, 4. Okay. Now, okay, let me just make sure. 1, 2, 2, 1, 3, 4, 1, and 3, 1, 2, 3, 4. Yeah, okay. So now let's look at this. Let's look at 90 degrees counterclockwise. Okay, let's see what's going to happen here. If we, if we went through and worked through this, what would happen to this point? Well, now remember we're going counterclockwise, so this is going to be -1, 2. See, I'm looking back at this thing. So now let's get the other points. So let's see what happens to 4, 1. Okay, so here's 4, 1. Well, this is going to be -1, 4. And this one over here is -4, 3. Now, let's see if that works out. So we got -1. Got this triangle, this line off a little bit. Okay, so we've got -1, 2. -1, 1, 2. Okay, there's a point. -1, 4. 1, 2, 3, 4. Okay. And then -4, 3. 1, 2, 3, 4, 1, 2, 3. Okay. Okay, so there's our 90-degree rotation. Now we can do the same thing for 180. So let's look at 180, counterclockwise rotation. So let's see here. What happens? With the 180, we just negate the x's and the y's. Yeah, there it goes. See, we did that one. So let's see what we got down here. We got -2, -1. We've got -4, -1. And then we've got -3, -4. So this is the 180 degrees. Okay. And then we could do the 270. Okay, so here we go. So this one, the y goes here, and then the -x. Okay. The y goes here, -x. Y goes here, -x. So let's see what we've got. We've got 1, -2. Okay. We've got 1, -4. And then we've got 4, -3. And there is the triangle. Okay. See? Yeah, that's it. That's the way we do this. Now look, we've also got this thing called rotational symmetry that we want to look at. Imagine that you're just wanting to spin the figure around. Okay? So think about a square, and think about a point, a center of rotation inside that square. And think about if you rotate that square, let's say 45 degrees counterclockwise, or clockwise, let's say. Notice this red line here is now over here. You've rotated 45 degrees. If you rotated another 45 degrees, dig what you have. You have exactly the same shape. You can't tell the difference. So this is called rotational symmetry. Now, other things have rotational symmetry. Notice this octagon here. Like if I rotate this octagon, let's see. Well, it's not giving me my rotation bars, but notice if you rotate this thing, you know, this regular octagon, you have a rotation right. Oh, there it goes. So notice if I rotate this a little bit, there it goes. Okay, notice if I rotate it, I don't have to rotate it much, and I get the same thing back. Okay, so they're rotated again. See? So this has rotational symmetry. Now, so over here, this one. Okay, rotational symmetry. Notice this one doesn't look so much like it does, but look, if we rotate it 180 degrees, we kind of get the same thing back. This is called rotational symmetry. Now, this trapezoid doesn't have any. I mean, you can look at that and say, yeah, that thing doesn't have any. When we talk about rotational symmetry, we're talking about a rotation of 180 degrees or less. In other words, yeah, like this trapezoid, you're not going to rotate it 360 degrees. It's 180 degrees or less. And that's what we mean when we say rotational symmetry.